My name is Sam Ponnada. I'm a senior majoring in physics, astronomy, and math, and I'll be talking about Gravbox using augmented reality to communicate topics and foster interest in physics and astronomy. So the main purpose and goals of my project were to, one, communicate topics about gravity to a broad audience using a state-of-the-art science communication tool, in this case, Gravbox. Secondly, I wanted to provide a physics and astronomy outreach event for junior high students from underprivileged and underrepresented backgrounds. So physics is one of the scientific disciplines with some of the highest disparity in the representation of minority groups at both the bachelor's and the doctoral level. And there have been studies which have argued that some of this is attributable to the lack of high quality hands-on K through 8 education, specifically on physics and astronomy. And thirdly, I wanted to raise interest in physics among junior high students, as well as communicate important scientific ideas about gravity specifically to both the general and the specific audience of junior high students from underrepresented backgrounds. So some of the key resources for my project are, of course, Gravbox, which is an outreach tool developed by the 2016 Introduction to Astrophysics class at the University of Iowa. And so an image of Gravbox is shown here. Gravbox is a physical box of sand in which a deeper hole in the sand corresponds to a more massive object, which would have a deeper or stronger gravitational potential. So how it works is that when the user creates a hole in the sand, there's a 3D camera up here that reads the depth of the sand, and there's a computer housed underneath the box that computes a simulated gravitational field corresponding to that depth. And this is then projected back onto the sand using a projector. And finally, the computer generates a test particle whose motion is determined as it would move through this gravitational field, and it's also projected onto the sand. This demo device is currently housed at the Eastern Iowa Observatory and Learning Center, pictured here. The EIOLC is just outside of Solon. It's around a 30-minute drive from Iowa City. And thirdly, one of my main partners I was hoping to partner with was Big Brothers Big Sisters of Johnson County. Big Brothers Big Sisters is a community volunteer organization that pairs K through 12 students, which are dubbed littles, from disadvantaged socioeconomic backgrounds with adult mentors who are called bigs, who are usually college-aged adults or older, to form a positive relationship in the lives of the students with good role models who encourage educational success. And finally, the University of Iowa Society of Physics students was going to help me in volunteering at my event that I plan to host at the EIOLC, which I'll talk a bit more about. So my project was focused on two audiences. The first audience was the general public nights at the EIOLC that happen every month. And so these are usually in the format of a talk, which is followed by stargazing or observing through telescopes. And I wanted to have Gravbox demos there so people could come check that out while also going to see the other telescopes and stargaze. And the second audience was, as I mentioned before, junior high students who are in the Big Brothers Big Sisters program. And so my project really had two main events in mind. So the first was a public night presentation that I gave at the Eastern Iowa Observatory on October 19th. So I actually gave the talk that night myself, followed by a demo night for around an hour. And the second event that I had planned was the Big Brothers Big Sisters Physics and Astronomy demo night and star party or stargazing night at the observatory, which unfortunately was canceled due to COVID-19. So public nights, I was usually doing demos for around 1.5 to 2 hours after the public talk of that night. It really just depended on how many people were there and how late they were staying at the observatory. A very wide audience range, all the way from kids to elderly folks. Usually at least between 10 to 20 people stopped by at these public nights, and questions that I fielded ranged from answering questions about the Gravbox itself to careers in astronomy and physics and education. And these questions were from students as well as concerned parents as well. And so the EIOLC talk that I gave, there were more than 40 people in attendance. I gave a 20-minute talk about Gravbox, and then this was followed by questions and around an hour of demos. And so here are some photos from the public nights as well as my talk at the observatory. So here, a picture just making a simple circular divot in the sand on a September public night. And here's the test particle that's moving according to this gravitational potential. It's falling in towards this strong gravitational potential, since here it's deeper than up here. Over here on the right is a photo from my post-talk demo night. on the October 19th public night. This was actually featured in the Prime Focus November newsletter that the observatory sends out to its members every month. So there's quite a large crowd here checking out Gravbox, and this is actually one of the patterns that they made in the sand with almost four different deep wells, which could represent something like a four planetary system or something like that. And again, you can see this test particle moving according to this gravitational potential made in the sand. So the Big Brothers Big Sisters event that I had planned to hold was supposed to be held on March 28th. It was going to have between 10 to 12 mentor-mentee pairs. I was planning to have 45 minutes of Gravbox time, followed by 45 minutes of stargazing and observing with the observatory telescopes. And first, there was going to be a simple demo trying to illustrate the effects of gravity, and a simple discussion about gravity, trying to see where the audience members, both the students and the mentors, were on their understanding of what gravity is and how it affects us in our daily lives. And this would be followed by splitting the audience into groups of 3 or 4, and each group would be given a different model sketch to create on the sand. And this would be followed by a discussion about what each group could be modeling. So I could give a group something like a simple hole in the sand, a circular hole that could represent something like the Earth, and the test particle could be something like a satellite, or they could be given a pattern that has 2 big holes in the sand, which could be something like the sun and or the Earth and the moon, something like that. And they could try to figure out what kind of object or what kind of system that they're modeling. And finally, after this modeling and this discussion was done, it would be followed by stargazing and telescope activities. So while this event couldn't happen, I did create a full 3-page lesson plan and demo guide that I hope will be used in the future. And as I mentioned before, the main goals of the demo and the lesson are to convey the idea that gravity is an attractive force that depends on mass and distance, and to relate the concept of gravity to our own solar system and Earth, so some simpler astronomical examples, as well as to convey the idea that massive objects affect the space around them through the concept of a gravitational potential. And so this guide will be given to the Society of Physics students and the Eastern Iowa Observatory in hopes that they can be used in future demo events that take place at the observatory. In conclusion, I did manage to achieve the goal of communicating topics about gravity to a broad audience. However, I was unable to achieve my goal of having an outreach event specifically for junior high students, even more specifically from disadvantaged backgrounds for the Big Brothers Big Sisters program. But I'm hoping that I managed to lay a foundation for this event to take place in the future with the lesson plan that I've made, as well as connections that I hope that the Society of Physics students will be able to maintain with Big Brothers Big Sisters of Johnson County. And finally, with all of the uncertainty that plagued this semester, I definitely managed to learn to go with the flow and account for setbacks, which is a very useful skill that I will have with me for the rest of my life. So finally, I'd like to thank Brenda and Lori for being truly amazing mentors throughout this entire project. I'd like to thank the Lathams for, of course, funding this program. I'd like to thank Dr. Scott Bounds and the observatory for allowing me to demo at public nights and host a talk myself, as well as host the event that I had planned to have with Big Brothers Big Sisters in March. I'd like to thank Ken Fate, who was my main liaison at Big Brothers Big Sisters. I'd like to thank my mentor, Professor Hai Fu, who oversaw the group that created Gravbox and encouraged me to use Gravbox for these demos and events. And I'd like to thank Society of Physics students for being willing to volunteer at my event, as well as all the other fellows for being so supportive and providing feedback throughout this entire process. And that's the end of my presentation. Thank you very much for watching, and I hope you check out the rest of the presentations from the other fellows as well.